Hello everyone. In today's video, we are moving on next to important concept in differential equation, which means the order and degree. So definition of order and degree. Order is the highest derivative order and degree is its power in the equation. So let's start with order. The order of differential equation simply tells you the highest level of differential derivative present in the equation. Highest derivative in the equation. So in other words, you just look at all derivatives involved and pick the one with highest order. So that's it. No complicated thing required. So if the equation contains only the first derivative, it's first order equation. If it goes up second derivative, then it's second order differential derivative, and so on. So basically, order is all about the identifying how deep differentiation goes. Now let's talk about degree, which is the slightly more tricky. So the degree of the differential equation refers to the power of highest order derivative. So from this example, mm, the order is second order differential equation. So order is the most highest power order derivative. Its power is the degree. So the equation must be free from radicals and fraction involving derivatives. In simple terms, the equation should in a proper algebraic form before you can talk about degree. So once that condition is satisfied, you look at the first highest order derivative and check its power. So that power becomes the degree. So, what makes a degree confusing for many students that it does not always exist. If the equation contain derivatives inside function like square roots, denominator or trigonometric expressions, then the degree is not defined. So, unlike order, which always exists, degree depends on the form of the equation. So, another important thing is understand is the difference between order and degree. Order is about the level of differential derivatives, while degree is about the power of the derivative. So order is the level of the derivative and degree is the power of the derivative. So students often mix these two up, but once you clearly separate these ideas, it becomes much easier to handle equations. In engineering examples, questions on order and degree are usually straightforward, but they required careful observation. A small mistake in identifying the highest derivative or misunderstanding the form of the equation can lead to the wrong answer. Overall, this topic is less about calculation and more about clarifying of concept. So once you understand what you look for, you can answer these questions quickly and accurately. That's it for today's video. If this help, the next thing is a general and particular solution. So when you solve the differential equation, you usually end up with an answer that contains a constant. So this constant represents a whole of possible solution rather than just one. In a simple terms, the general solution is a general solution that not a single curve or result. So it represent I infinitely many solutions that all satisfying the given differential equation. that that's why it's called the general, because cover all possibilities. Now there it represents the complete set of solution containing arbitrary constant. Now why do we get the constant in the first place? So it becomes from the process of integration. Whenever we integrate, so the constant term must comes. This brings us particular solution. A particular solution is obtained when we are giving some extra condition, usually called an initial condition or boundary condition. This condition helps us fix the value of that constant. So the difference is simple but powerful. That is, the general solution represent all possible solution, while the particular solution represent one specific solution that satisfying additional condition. So thank you.